This video looks at applied questions needing simultaneous equations, and simultaneous equations is a common method for solving application questions. So firstly, when solving problems, you need to translate words into mathematical equations. Once you have two linear equations with two variables, you can solve them simultaneously using either the substitution or elimination methods. It's up to you. Now, the key point is to remember to always define your variables. If they're not defined in the question, you have to do it. And the key is whatever you're trying to find will be what your variables are. So it's a good way to set your question up. So this first one, I received better results for my maths test than my science test. So that means that the maths mark has to be greater than the science mark. If the sum of the two marks was 164 and the difference was 22, determine the mark for each subject. So first of all, we have to define our variables. Now we're looking for the mark for each subject. So let mark for maths be M and science be S. Make sure your S looks different to a 5. Now let's go back to what the question says. The sum of the two marks was 164. So M plus S has to equal 164. The difference was 22, knowing that maths was greater than science. So that means maths minus science was 22. We have equation 1, equation 2, and the quickest way with a plus S and a minus S, just add the two equations. So if you go 1 plus 2, M plus M is 2M. Our S's go 164 plus 22 is 186. Now note, I could have subtracted my equations and I would have got rid of the M's. So it doesn't matter which way you go. Divide both sides by 2, so M is 93. Sub M equals 93 into equation 2, because it's got smaller numbers. So 93 minus S equals 22. Take away 93 from both sides. Minus S equals 22 minus 93. In hindsight, I should have probably plugged into the other equation. I wouldn't have had to deal with the negative. So if negative S is negative 71, S must be 71. So therefore, maths mark was 93 and science mark was 71. And you can quickly check these without going back to the equations. The sum of the two marks is 164, so 93 plus 71 is 164. The difference is 22, so 93 minus 71 is 22. So I know it's correct. So always remember to check your answers. Next one, a rectangular house has a perimeter of 40 meters and the length is 4 meters more than the width. By first defining a set of simultaneous equations, calculate the dimensions of the house. Whenever I think about a question like this, I like to have a drawing. Okay, so a rectangular house has a perimeter of 40 meters and the length is 4 meters more than the width. So length and width, and length is going to be W plus 4. So let's look at what we've got. Perimeter is 2 lots of my length plus 2 lots of my width, and we know our perimeter is 40. So 2 lots of the length plus 2 lots of the width. We also have that L is equal to W plus 4. Now I can simplify this equation here by dividing everything by 2. So 20 equals L plus W. So equation 1, equation 2. L is out on its own in equation 2, so I'm going to substitute. I'm going to sub 2 into 1. So I have 20 equals, so I'm going to put this W plus 4 where the L is. So 20 equals W plus 4 plus W. Collect my like terms. So 20 equals 2W plus 4. Take 4 from both sides. 16 equals 2W. Divide both sides by 2. So W equals 8. Sub W equals 8 into equation 2. L equals W plus 4, which is 8 plus 4, which is 12. So therefore, length of house was 12 meters and width was 8 meters. 8 plus 12 is 20. 2 lots of 20 is 40. So the perimeter is right. My length had to be my width plus 4. 8 plus 4 is 12. So I know I'm correct. Okay, remember to check. Okay, Joel has 5 lemons and 3 oranges in his shopping trolley, and the cost was $3.50. Mike has 2 lemons and 4 oranges and pays $2.10. By first defining the set of simultaneous equations, calculate the cost of each type of fruit. So that last sentence tells us what our variables are. So let cost of a lemon equal L and cost of an orange. Now you can't let it equal O because it'll look like a 0. So I'm going to use G. So Joel has 5 lemons and 3 oranges and he's cost $3.50. To make it easier, let's go 5L plus 3G equals 350. Now Mike has 2 lemons plus 4 oranges and he paid $2.10. So that's going to be 2L plus 4G equals 210. Now you wouldn't be using substitution here. You'd have to be going for elimination. So equation 1, equation 2, I'm going to aim for 10L. So I'm going to go equation 1 times by 2. So it's going to be 10L plus 6G equals 700. That's now equation 3. Then I have to go equation 2 times by 5. So that becomes 10L plus 20G equals 5 times 210 is 1050. Okay, you're better off going equation 4 minus equation 3. So 20G minus 6G is 14G, and then 1050 minus 700 is 350. If you go 3 minus 4, it'll still work, you'll just end up with negatives. Divide both sides by 14, and G ends up being 25. Sub G equals 25 into, let's go equation 2, doesn't really matter, 2L plus 4 lots of 25. So we're just putting this 25 where that G is in equation 2. equals 210. 2L plus 4 lots of 25 is 100 equals 210 minus 100 from both sides. 2L equals 110. Divide both sides by 2 and L equals 55. Therefore, an orange costs 25 cents and a lemon costs 55 cents. Now, I'd recommend checking this one. So we checked in equation 2, so let's look at equation 1. So 5L plus 3G equals 350. My left-hand side is going to equal 5 times 25 plus 3, 5 times 55, sorry. 5 times 55 plus 3 times 25, which equals 5 times 55 is 275. 3 times 25 is 75, and that is 350. So I know I'm correct. Last example. In 5 years' time, Mike will be 4 times as old as his son Toby. Two years ago, Mike was 11 times as old as Toby. Determine the present age of Mike and Toby. So that last sentence is what our variables need to be. So let present ages be M for Mike and T for Toby. We've defined our variables. First one, in 5 years' time. So in 5 years' time, we're going to be dealing with M plus 5 and T plus 5. So that's very critical when you're coming up with your equations. So in 5 years' time, Mike will be 4 times as old as his son Toby. So that means M plus 5 has to equal 4 lots of what Toby is in 5 years' time. So M plus 5, let's expand our brackets, is 4T plus 20. Get M on its own. M is going to be 4T plus 15. Just taken 5 from both sides. So we have our first equation. The next bit, it said in 2 years ago. So 2 years ago, we would be dealing with M take 2 and T take 2. So 2 years ago, Mike was 11 times as old as Toby. So that means that M take 2 was 11 lots of T take 2. So M take 2, expand brackets, is 11T minus 22. Again, get M on its own. M has to be equal to 11T minus 20 because I've just added 2 to both sides. So that's my second equation. So I have 2 equations. M equals 4T plus 15. That's my equation 1. And I have M equals 11T minus 20. That's equation 2. M is the same in each. So sub 1 into 2, and we have 4T plus 15 has to equal 11T minus 20. Unknowns on both sides. I'm going to put my T's on that side because that's where the highest coefficient of T is, and my numbers on that side. So I'm going to take 4T from both sides, and I'm going to add 20 to both sides. So you can see the T's are gone and the 20's are gone. So I'm left with 15 plus 20 is 35. 11T minus 4T is going to be 7T. I then have to divide both sides by 7. So T equals 5. Sub t equals 5 into one of the equations. Let's go into equation 1. So m equals 4t plus 15. So it's going to be 4 times 5 plus 15. 20 plus 15 is 35. So therefore, Mike is currently 35 years old and Toby is currently 5 years old. And go through and make sure that that makes sense. Substitute into your equation. So we substitute into equation 1 to find our m. So if we check using equation 2, which was m equals 11t minus 20, the right-hand side would be 11 times Toby, which is 5 minus 20. 11 times 5 is 55 minus 20, which is 35. And that's our left-hand side because that's what Mike is. So we know that's correct. So practice your application questions. My recommendation, if you can solve by elimination, solve by elimination. Okay? The key is the last sentence usually tells you what your variables are.